In this lecture, we will discuss the types of random variables. This lecture is a part of our course on discrete random variables and probability distributions. If you want to learn this topic in a step-by-step and detailed manner, then you may check the description of this video to get the access link to our full course. All that said, let's get started with the types of random variables. There are two types of random variables, discrete random variables and continuous random variables. Let's start with discrete random variables. By definition, a discrete random variable is a random variable that may assume either a finite number of values or an infinite sequence of values in which there is a first element, a second element, and so on. There are two terms to understand here, finite number of values and infinite sequence of values. Let's take a couple of examples to understand what do these terms mean. Say you want to inspect a shipment of 25 machines, and this is how you have defined your random variable. The random variable x is the number of defective machines. Here the possible values that x can take range from 0 to 25. So here the random variable x is assuming a finite number of values, and that finite number is 26. So our random variable x can assume any of these 26 values. Okay, so in this case we can see that x is a discrete random variable. Let's take another example. Say you want to test 9-volt batteries and you decide that you will keep on testing until one battery with an acceptable voltage is obtained. In this case, these are the possible outcomes. Here F means that the battery failed the test. That is, the battery does not have the acceptable voltage. And S means that it is a success. That is, the battery has an acceptable voltage. So the first outcome here means that the very first battery that you tested passed the test. That is, that battery has an acceptable voltage. The second possible outcome means that the first battery that you tested did not have an acceptable voltage. Consequently, you decided to test one more battery, and the second battery that you tested does have an acceptable voltage. So this is how you can interpret these outcomes. Now let's say that this is how you define the random variable in this case. So the random variable x is the number of batteries tested before the experiment terminates. So the value of x corresponding to the first outcome is 1. The value of x corresponding to the second outcome is 2, and so on. Basically note that in this case the random variable x can assume infinite values. Any positive integer is a possible value of x, and this is what is called countably infinite. Basically it means that you can start counting the values of x. This is the first value, this is the second value, and so on. But the counting will take forever because there are infinite values. So if you have a random variable that has countably infinite values, then that random variable is a discrete random variable. Let's move to our next example now. Say I ask you a question related to microeconomics. Now, either you know the answer or you don't know the answer. So these are the only two possible outcomes that we have here. Okay? And let's say this is how we are defining the random variable x. So the random variable x is equal to 0 if you don't know the answer, and the random variable x is equal to 1 if you know the answer. Note that the way we have defined the random variable x is completely arbitrary. The values of the x here are not based on any rule. I've just given some arbitrary values to the random variable. The value is 0 if you don't know the answer, and the value is 1 if you know the answer. Now because this random variable can assume only two values, that is 0 and 1, so by definition this is a discrete random variable. Also note that as we are assigning arbitrary values to the random variable x, it is not necessary to assign the values 0 and 1. You can assign any values. You can assign 2 and 3, or you can also assign 5 and 10 if you like. But if you assign the values 0 and 1 to the random variable x, then we can give a special name to our random variable, Bernoulli random variable. By definition, a random variable that can assume only two values, that is 0 and 1, is called a Bernoulli random variable. So this is all about discrete random variables for now. Let's move to continuous random variables. By definition, a continuous random variable is a random variable that may assume any numerical value in an interval or collection of intervals. Let's take an example to understand this in detail. Say we want to test my fitness, and this is how we have defined the random variable x. So x is my weight in kgs. Let's say that I am absolutely sure that my weight is somewhere in the range of 65 to 70 kgs. In this case, we can say that the random variable x is a continuous random variable as it can take any numerical value in this interval. My weight could be 65.27389 kgs, or it could be 67.35612 kgs, etc. etc. So there are infinite possible values of x, or I should say, x can take uncountably infinite values in this case. Uncountably infinite because you cannot even start counting these infinite values. I mean, what will be your first element if you decide to start counting these values? Do you think taking 65.1 as the first element is a good choice? Well, why not 65.01? Or why not 65.0001? Well, this can go on and on. So you see, you cannot even start counting these infinite values. So that's why they are uncountably infinite. There is one more important point that you should keep in mind while dealing with continuous random variables. In case of continuous random variables, the probability of an individual value is virtually zero. For example, if I ask you what is the probability that my weight is 69.238754, you would say almost zero, right? And this is because the random variable x, that is my weight, can take infinite values in the range 65 to 70. So the probability that my weight is equal to a particular value is virtually zero. So this means that while dealing with continuous random variables, we can determine the probability of only a range of values and not a particular value. So we can determine the probability that my weight is between 65 and 66 kgs, or say the probability that my weight is between 69 and 70 kgs. All about continuous random variables. I hope this lecture has given you a fair idea of the types of random variables.